Yep.
All right. Welcome to the part 2 of TLS at IETF 102. And you probably have all seen this note well. I'll put it up real briefly here so you can peruse it. But now we'll move on to agenda for today. I think there were a couple things we wanted to start with. One is that we did have a side meeting this week on the DNS sec chain extension. And I think it was a productive meeting. There's some additional discussion to be had on the list. And we'll probably try to schedule a virtual interim to get parties together again to see if we can continue to make progress and close the issues and get a document out in the near future. In addition,
So David Benjamin was kind enough to publish a new version of the TLS Grease draft. And I guess what we're going to do is try to just go directly to the horse's mouth and go talk to the IANA people. And I'm going to do that to try to make sure that the instructions are clear enough for them to understand what we're trying to do so that we could actually get this stuff implemented. And I think that ought not be hard because they're here. And I've been talking with them about lots of other IANA registry related things. So I will go ahead and do that and report back as soon as possible.
All right, so before we get into the main talks, does anyone want to bash the agenda? One quick thing to note, Richard Barnes didn't send an update to the PEG draft that is not reflected in this agenda, so he will have 5 minutes before the ticket request slot. But anything other than that, please come up now. Ben.
Ben Kaduk. Is this on? Ben Kaduk. So, with no hats on, there's a question that's come up about the reuse of PSK shared keys between TLS 1.2 and TLS 1.3. And sort of my intuition is that if you have an existing PSK that you're using for TLS 1.2, you don't necessarily want to just drop that into TLS 1.3 with a different key schedule and, from a cryptographic point of view. I don't know that there's any real value in us talking about that today. But I do think that if we decide that you should not do that, we might want to have some text about that in the TLS 1.3 document, which is potentially done in timescale of weeks. So if you do feel like you're qualified to have a cryptographic opinion on does this actually matter, please think about that and post to the list. This is sort of related to the topic that David Benjamin had brought up about the universal PSKs.
Yeah, Hannes.
That sounds a little bit surprising that you can't use your PSK from when you, specifically since we allow negotiation between 1.3 and 1.2 fallback, so it appears that you start with you want to do authentication and then, it surprises me, it doesn't sound right. It sounds like if you have the negotiation mechanism, it's the same, it's like saying you can't use a certificate now that you use for 1.2, not for, you have to get new certificates when you use 1.3. Yeah, no, but it's the same argument, in my opinion. But maybe not.
I mean, Ecker, do you want to okay, please. Yeah, Eric Pascola. The executive summary is that the cryptographic analyses of 1.3 basically assume that any PSK is only used with a single key duration function. Now, am I aware of any actual problem if you don't do this? No. But basically, the cryptographers are like, I won't make any guarantees if you ever mix and match keys with different key duration functions. So, I'm not aware of any reason to believe this is actually a problem, but that's what's going on.
David Benjamin, just to add to that briefly, the reason the certificates are okay to be reused is because we, in the certificate verify, am I not speaking tonight? Sorry, David Benjamin, to add to that, the reason the certificates are okay to be reused as is because we explicitly add the context string in the protocol has the 64 spaces to clear the client random, so that's why the certificates are safe to use between the two. the PSK does not immediately have that. I feel it should be pretty easy to fix. You just like say you derive it with this thing that looks like the TLS-12 PRF. How much we care is another question.
So, in my opinion, a good approach would be to actually let the formal message guys analyze that case as well before we go ahead and make these sort of potential suggestions and confuse people.
Right. So I think that needs more discussion on the list. So I think let's go and start with our regular agenda. So certificate-based authentication. Russ, you're up.
Just escape. Hi. So the reason that I'm up here is because we ran out of time in London and I didn't get to do this presentation then. Next slide. So the current TLS 13 authentication and key schedule basically, yeah. Make it all fit on the Oh, there we go. So, the initial handshake basically uses a signature and a certificate to do the authentication, and the Diffie-Hellman result is the thing that drives the key schedule. I thought it was. Okay, and the subsequent handshakes are based on the resumption PSK or a combination of the resumption PSK and an additional Diffie-Hellman result. Next slide. What I'm proposing is that we add an additional option to the initial handshake that lets you include an external PSK and combine it with the Diffie-Hellman result. Next slide. And the reason I would like to do this is quantum protection, just in case the quantum computer comes to pass. The idea is that you mix this externally generated out-of-band distributed PSK so that any traffic that is recorded now the attacker has to not only get a hold of a quantum computer, but also has to get a hold of that PSK value. Next slide. So this slide just demonstrates where it would fit. The extension that says I want to mix an external PSK is included, and then existing extensions are used to distribute the pieces. So the key share and the exchange mode and the pre-shared key are used as specified. It's just this one extension that, if it's present, says mix the two together. Next slide. So the syntax is at the bottom of the slide. You can see it's empty. It really is a Boolean. It's present or it's not. And so if you successfully negotiate that, you're basically just saying, we're going to do that. And then the other three extensions must be present to provide the information about which external PSK and provide the Diffie-Hellman values. Next slide. So presently, there's language in the spec that does not allow the PSK to be used when certificates are used. That's the whole reason for the extension, is to override that statement. However, I'm still saying that certificates would not be used with a resumption PSK. They would only be used with a external PSK. Next slide. So a few thoughts about the external PSKs. Basically, a group would need to be a group of
entities that are doing TLS would need to get a hold of these PSKs. Pairwise PSKs between everyone that might be communicating is not feasible. That would recreate all the key management problems. But the idea is that if the quantum computer comes to pass, then you have to get both of the values from, you'd have to compromise one of the members of the group in order to get the PSK, in addition to getting a hold of the yet to be invented quantum computer. And so for that reason, the external PSKs will be more suitable for some applications than others, but let's protect the ones that do need it. Next slide. So the ask is that the working group adopt this as a work item, and then questions?
I don't know if it's a question, but the way you're phrasing the semantics are a little odd in that external PSKs already can be Mr. Diffie-Hellman, and that's the way all PSKs work in 1.3 if there's Diffie-Hellman involved. So the semantic, it seems like you're saying, is not makes the semantic here is allow certificate is instead of bypassing the certificate is I would like you to send a certificate signature even though you're doing PSK. That's the semantic I think that is relevant here, correct?
Okay, help me with the language, but what I'm saying is right now the authentication is, if a PSK is present, the authentication is based on that.
Yes, I agree.
Okay, what I'm trying to say is I want to mix the external PSK and have the authentication based on the names in the certificate.
I'm a little...
Because the PSK will be a group, not a...
No, I understand. I get that part. I mean, I may be nitpicking, but the protocol semantic, the authentication is a difficult semantic because TLS is like really vague on what authentication means. But the protocol semantic is, I insist that as well as using this PSK, you also generate a certificate and certificate verify.
And take the identity from that certificate, not because the external PSK won't have this.
Sure, I'm just saying it's not a, I mean, yes, but TLS has nothing to say about that. TLS, like, once the handshake is complete, the client evaluates it in the manner of his choosing, right?
Got it. I see what you're saying.
Would you be expecting to relax the restriction on client authentication as well?
Yes.
Okay. Not sure what I think about
Yeah, in
that.
fact, I explicitly said somewhere
I
in
thought
the
you did, yeah.
draft that client authentication could be used as well.
Right.
Certificate-based client authentication.
So yeah. Okay. I'm not sure what to think about this. Think about that. I mean, so as you recall, this was removed for two reasons. One, a vertical complexity reason, I think suggested by Sabode or David Benjamin, and the second, because there were known attacks on at least one variant of the TLS key schedule. I believe my understanding is that has been fixed.
That is my understanding.
But we would, like, I don't know as a process matter where we should be, but like before we got very far with this, I would want to see a formal analysis with Provera or Tamarind that showed this was okay.
Sure, but it's my belief as well that was fixed. Martin.
So Martin Thompson, I think you've specifically excluded the one use case that I actually care about in all of this by saying that you wouldn't allow this with resumption PSKs. I don't think that distinction is actually useful here. I think to Eko's point, when you complete the handshake and you have both the PSK and the certificate, you make an assessment of whether or not to continue with it. That's a useful property to my mind, particularly because if you recall, I wrote a draft a very long time ago, but back sort of the middle of the design process where the concern was that there was no fresh proof of ownership of the server certificate if you have a long series of resumptions. And clients that are using zero RTT would be presented with a trade-off. They would have to choose between zero RTT or re-upping on the certificate. And if you were able to combine the two of them, it would be quite useful to do that.
Okay, so,
So I think-
I was trying to make the smallest change to the,
I think you made a bigger change than what was necessary is the point.
you do? Yeah, I'd like to talk about that more.
Yeah. So I think having a signal saying, in addition to this PSK, I expect you to also authenticate with a certificate
Mm-hmm.
to a server would be a valuable signal to have, and that may be sufficient. The use of client certificates in this one, yeah, I hadn't thought that one through, and that one probably
Yeah, I
needs a
just-
little bit more work.
I just didn't come up with anything that it broke.
Yeah.
Yeah, okay, well,
Nick Sullivan, Cloudflare, I would second Martin's point that it would be useful to have this for PSK for resumption as well as static, and I think it's generally a good idea.
okay,
So I'm
cool.
supportive.
Well,
While you're responsible for this, plus, I want to repeat my comment that I did in lamps, that we have in IPC community, we have a draft that uses a similar technique, and the draft is already in the GLC state, and we use slightly different terminology. The PSK is called PPK, post-quantum pressured key, so probably you consider harmonizing so that across the document using the same technique, the terminology is the same.
so in this particular case, I'm not sure I can align with that terminology because the base TLS document already is very specific about resumption PSKs and external PSKs, but I will look at that question.
Okay, thank you.
Hi, David McGrew, Cisco. So I just want to, speak to the goal of securing TLS against the potential of a quantum computer. And this would greatly expand the number of post-quantum secure cipher suites and be consistent with certificate-based authentication. And that's a really good goal.
So you're saying you're supportive?
Yes.
Okay, thanks.
Okay, real quick, because we're kind of short of time. There seem to be some people who are in favor of it. Can I get a show of hands who's actually read the draft? So a number of hands. Potentially, continue discussing on the list, and then maybe next time we call for adoption if you'd like.
So how about we start a call for adoption and all these comments will come out?
That works for me. All right, Richard. Hey, so this is TLS PIC. We had a similar lightning talk shaped talk about this at the last IETF and produced a new rev. This slide is the same as the last time. Motivation is the same. Sometimes you need a password that doesn't have much entropy and you need to use it safely. The difference between last time is we published a rev of our draft mid-cycle this time, which contained a number of typos that we fixed earlier this week. But what that does, we had originally proposed binding this mechanism specifically to SPIC2, and the new draft has a generic PIC container. So it's got basically a blank, put whatever you want here extension in the client hello and server hello, that any given PIC protocol can put messages in, provided that the finished messages provide sufficient key confirmation. The other thing the draft does is say, when you get a symmetric secret out of this PIC protocol, here's where you put it in the key schedule. So it's pretty general. It has that general framework and it has a realization of it in particular for SPIC2. Been talking with Hugo some about doing this opaque as well, so that may show up in a later rev. So like I said, since the last time we got some feedback on the list about other PICs people were interested in, Dragonfly, opaque, a couple more, and so that led us to refactor into this general framework. So we've still got a couple of open questions. For instance, do we need to protect the identities that we're sending? Right now, the first message, the client hello, first PIC message in the client hello has to specify what password you're talking about, typically referred to as the identity, and there's no mechanism right now to protect that. So there's a question as to whether, we might try and do some hello retry request dance to do identity protection. Similarly, right now there's no mechanism to negotiate which PIC you're going to use on a given session. There's an assumption that when you pre-configure the password, you also pre-configure what PIC you're going to use it with. So, I say I'm going to use password 12345, and I'm going to use that with opaque. Because there's this pre-setup that's assumed between the client and server. Now that may not always be the case. For instance, if you're just typing a password into a client, it might need to discover from the server what PIC it should use that with. And so there might, again, need to be some hello retry request stance. But wanted to pose to this group now this question of whether developing some sort of PAKE solution to go into TLS is of interest, and whether this seems like broadly the right approach. So with that, I'll open up for questions. If the chairs want to have a show of hands or anything. I mean, I don't think we can go to an adoption request here because we're short on time, but maybe we could gauge some sentiments in the room to do an adoption request on this later. Yeah, I think that's a perfectly reasonable idea. Per Richard's suggestion, can I just get a show of hands of who is generally in favor of this work, who is interested in it, and potential. Okay, your hands go up. So, yeah, about 10 or so. Echo, do you want to comment real quick?
Can I ask who will implement this?
I'm like asking who in the room would implement this.
Right, so I would write patches for, probably OpenSSL.
Yeah. Okay. Is that? Are you the only person in this room who would implement this? That seems like kind of an argument against adoption, to be honest. So there hasn't been much discussion about this on the list, so I prefer we take this to the list and then continue discussing it there if there isn't a sure. Up and increase. The reason I'm pushing back on this particular thing in this particular moment is that the history of PAKEs in TLS has been like a lot of effort spent in specifying them and very little effort spent in implementing them. And so, like, I'm not opposed to this if there's going to be uptake, but I just want to make sure like there's uptake before we do it. Yes.
Sure. Yeah, Rich Saul's OpenSSL. The patch won't be enough. We'd want to see it used in applications because we've already got like pull requests. I can get taller. The patch request, yeah, we wouldn't want to see it in OpenSSL unless there were application use. We just turned down JPEG because it's like, oh, it's an IETF standard, all that stuff that I've talked about before. So we'd really need to see other people needing this before we took it.
Yeah, so to be clear, I'm not here because I have an academic interest in PAKEs. I'm here because I had some product requests for people who needed something of this general form, who had a use case where they could only provision low entropy secrets and wanted to be able to authenticate with them. So, I mean, we would be pushing to put it in some products.
Yeah. Okay. I mean, generally, the concept I think is cool, but there's a limit.
I appreciate it. All right. Thanks, guys.
Yeah. Thanks, Richard. All right, so the chair had off for this presentation, and we have to be really snappy because we're kind of short and behind on time. This is something we brought to the list a while back, I think in April. Take a request, you might be able to wager what that means. So we'll get right into it. The basic problem that we ran into is that servers generally just send you a fixed number of tickets upon connection. So in the case of Boring SL, for example, they just mint 2 and send them to you each time. But potentially, if you're racing connections using Happy Eyeballs v2, and you open up parallel connections using resumption more than 2 tickets, or you want to do some kind of connection priming thing, you may want to get more tickets. But then again, if you are vended more tickets, you don't use them all, they kind of just go to waste. So it'd be nice if you had a way to sort of explicitly say how many tickets you need for your particular use case. So the request we outline in the document is basically a request response protocol and post-handshake as a post-handshake message where clients will signal support for this particular type of post-handshake message, and servers who support it as well will hold off minting any new session tickets until the client then later asks for one in a post-handshake message in a request, and the request carries an identifier and some optional context, blah, 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 and some extensions that could be filled in later. Pretty straightforward. An alternative design we considered was basically expressing in the new extension how many tickets you might need up front, so then the server doesn't have to do any guessing or wait. It can just send however many it wants, or the minimum of what the client requests and what it's willing to vend. So if I ask for 1,000 tickets and the server's only willing to vend 4, then it would vend 4. And that's the best we can do in this particular case. And this is sort of nice in that it avoids having to adding more post-handshake messages, which can be quite nasty depending on your implementation and how you actually choose to go about doing this. But it doesn't allow for dynamic vending of tickets. I mean, of course, you could do various hacks like opening up a connection, getting 4 tickets, and then just repeating that over and over again to expand your pool of tickets. But this is pretty static in that sense. But again, utility of this particular mechanism depends entirely on the use case. So if, for example, clients will never ask for more than 4 tickets, why don't servers just start vending 4 tickets all the time instead of 2, and then we can just call it a day and go home and we don't need to make any changes. However, as I was saying, that it would be nice if we could kind of avoid, in the connection pooling use case where you might want to just build up a pool of tickets and use them to vend out to other processes to start up connections very quickly. If you could avoid a hack by, connecting, getting a bunch of tickets and slowly increasing your pool. So again, the goal is just to make this kind of explicit to avoid ticket waste, to make it very clear to the server how many tickets to send. That's pretty much it. There were some comments on the list about this. I think it's a pretty simple approach, and I'm interested to hear if anyone else is in favor of this particular idea or finds it pleasing or displeasing, what have you. Nick?
Nick Sullivan, Cloudflare. Have you considered making this an exporter in some way? Be able to export these, having post-handshake messages, as you mentioned, is pretty tricky in a bunch of implementations. Maybe you could export it. Is the use case you're looking at something in which you would use HTTP2 or some higher level application protocol to transport these tickets, or does it have to be in TLS?
No, we have not looked at it. Well, two answers, I guess. We have not looked at doing an exporter approach, and it is not strictly HTTP2. So potentially other applications or other protocols above TLS that would use this. Yeah. I think David was next.
David Benjamin. So I guess I'm going to say something which suggests exporters, but I feel really bad making just tickets exporters, so I'm not sure what the answer is. So one thing we ran into with the key update message was that, so suppose you have your read stream is going much faster than your write stream, like you're going over TCP and the other side's just not reading from you, so your write is backed up, or like their downlink is just slower or whatever, but they're sending you lots of ticket requests. You can sort of grow an unbounded number of ticket requests, and then, yeah, that's somewhat awkward for DOS reasons. Things like HTTP2 tend to solve this by saying like, okay, well, you're only allowed to have so many open streams at a time, and like the HTTP2 layer knows what that means and can deal with it. But since the TLS layer tends to be kind of this dumb pipe, things where stuff builds up can be a little bit awkward. I guess one obvious answer is we should just say that you're not allowed to have more than like 7 open ticket requests at a time, but that feels kind of weird and arbitrary. So I'm not sure what to do about this sort of thing. But.
Yeah, that was sort of the nastiness I was referring to earlier with the, potentially avoiding the post-handshake message and just shoving it, the actual number of tickets you want in, the client hello extension, and then not dealing with any kind of post-handshake message. So indeed, that may be the better approach if you consider this particular implementation bug pretty nasty. Yeah, Rich.
Yeah, Rich Salzakamai. Yeah, I mean, I guess the other alternatives we just universally deploy IPv6, but yeah, we do races all the time, and this would be helpful.
Yeah. Tommy. Tommy Polly Apple. So just echoing what you said, I think I want to reemphasize that we don't want a solution that relies on HTTP2 or a higher layer. This would be great to have just for raw TLS streams or any random application without having to extend them. I agree that point about the problems that can happen with building up requests is pretty bad. So I think that makes a pretty good argument for including them just in the initial. There could be, we're essentially 50-50 on that. There could be some cool ways of like, oh, I learned that I'm going to be doing more races and more connections to this connection later on. But I think optimizing it by having a best guess is just fine. Also to the point of racing, this isn't just happy eyeballs. So yes, V6 only is great, but we may have multiple V6 addresses as well as multiple paths, potentially even multiple protocols. Yeah. Yeah, I probably should have presented it as proposal 1 and proposal 2 instead of the main one and the alternate, but yeah. Kyle?
Kyle Eckertz. So issuing a ticket, depending on exactly how you're like encrypting or have like a distributed chaos, can very well involve some kind of an asynchronous request.
We're closing the mic up.
And before this, there wasn't really anything that could cause that after the handshake.
So I think from that perspective, that's kind of a nice property to have. If we can just like get the exact number of tickets that we want in the initial request.
Yeah, okay, so argument for option 2. So-
Kazuhoku, this might be a silly question, but could we use this to issue session tickets for different protocols? So that we could switch from HTTP to Quick, for example?
I mean, it's just a generic ticket, so.
But, well, tickets, especially for zero RTT, are bound to specific LPN.
Yes, good point. We haven't considered that particular issue, so I don't really have a clear answer for you on that, so thank you. Yeah, David.
So another thing that occurred to me, we haven't actually like played with this to see if this works out, but it did occur to us at some point that, oh, sorry, David Benjamin, I don't know if I said my name, that actually, even if you need, say, like 20 tickets, because you make 20 tickets in parallel, it's not obviously wrong to send only even one, because so the number of tickets you want is like the amount of like parallelism you have in your connections. If you make 20 connections, but they're all one after another, one ticket is just fine.
Correct.
And so if you make a resumption connection, you use one ticket and put one back. And if you make a fresh connection, either way, after a connection, you put a connection back. And so on startup, once you reach your maximum parallelism, like you will continue to have that many tickets going on at once, as long as tickets are always in fact, it doesn't matter whether or not you resume. If you use a ticket, you're going to get a ticket back, whether or not it's a fresh connection. And so it almost suggests that we should be just sending one ticket.
I mean, potentially. I mean, I think the utility, like I said, depends entirely on how you're erasing things and how quickly you're depleting your pool. So, I mean, you could start by erasing 10 and then getting 10 and then just continually going from there forward. Every time you resume, get 10 more or get one more and then just kind of march forward in time. Perhaps I'm misunderstanding your particular comment. Looks like Ben's going to get up, but I don't know if we have time, sadly. Yeah, sorry.
Yeah. I think what I'd like to know is understand how many people have read this draft. Okay. And how many folks think this is something the working group should work on? Just a couple hands. Okay. And how anybody vehemently opposed to this work? Okay. I think we obviously need to have more discussion on the list, but.
Yep. Cool.
All right. I'm going to pause just for a brief advertisement for EMU on Friday. Okay. We are going to talk about TLS topic, TLS 1.3 with IETF. So if you're still around, show up. It'll be exciting. All right. But even more exciting, encrypted SNI.
So unfortunately, we're kind of running short on time. So there will be some potentially controversial things in here, especially relating to DNS. So please ask if you have questions related to the DNS record format or anything. Please hold them to the end so we can kind of get through the TLS bits and then discuss that later or potentially on the list. So getting right into this, I think it's pretty clear that this is in the scope of the working group. I mean, we want to, as the text says, basically encrypt as much as possible and protect against passive and active attacks. And the SNI is something that's in the clear. Let's wrap it up. So with the development of TLS 1.3, we actually did pretty well in that respect. Most of the server extensions are now encrypted. Everything pretty much except the keep share and stuff is sent encrypted inside encrypted extensions. Their server certificate and the client certificate are both encrypted. Fortunately, the client extensions, in this particular context, the SNI, also things like the ALPN are sent in the clear. And these are sensitive things that you might want to hide from a privacy perspective. And you might want to hide this particular bit of information because, or depending on your particular threat model and what type of adversary you're dealing with. So if you're dealing with a passive attacker who just wants to sort of surveil you and learn out where you're going, hiding the SNI is certainly a good thing, I wager. If you're dealing with an active attacker who's trying to censor you based on your SNI, basically cut off an active connection to a website, this is also a good thing. I mean, there's a little asterisk there in that particular detail with regards to sticking out, but just move right along. So there's many different sources of server identity leakage, which the SNI, presumably indicates. The first, of course, is DNS resolution. The first thing you do before you start up a connection is actually just go talk to DNS and reveal to the world exactly what you're after. And there's the SNI itself. There was the server certificate back in the day. There is the server IP address, which may or may not be unique depending on your deployment strategy and how your application is actually hosted. And then the huge whopping bucket of traffic analysis and what you can do to learn where you're going and who you're talking to. So many things, fortunately, in the IETF have kind of plugged these holes. So the work in the DPRIVE and DO working groups have sort of, made DNS resolution private. Of course, modular traffic analysis and so on and so forth. This particular draft is, again, as the title suggests, interested in plugging the SNI hole. The server certificate was handled by TLS 1.3. Thank you, guys. The server IP address handled by CDNs and multi-tenanting. Asterisk there because it might be the case that particular applications are given a dedicated IP, in which case the IP just reveals exactly to where you're going, but there's work on that area as well. Unfortunately, this is still subject to traffic analysis like much of the internet, so can't fix all the world's problems at once. And as a working group, we spent a lot of time on this particular issue, going back pretty much to the start of TLS 1.3. There has been many different proposals, many different individual drafts if you were to go through the archives. And we have spent a lot of time trying to actually nail down what the problem statement would be, what the requirements should be, pointer to the SNI encryption draft from Christian, who unfortunately couldn't be here today, and Eric. And this draft very recently turned into two proposed solutions to these are the requirements for SNI encryption and how you should assess a particular solution. So we tried to take care to assess our particular design in the context of this draft and its requirements. And back in the day, before we had DO and DNS or DNS privacy, we basically, decided that this was a really hard problem to solve because there were so many different information sources or possible ways that this information could get out. So, I don't want to say why bother, but it was a hard thing at the time. Fortunately, that's changed now. We have DNS privacy, we have DO, and if you have massive, CDN servers that are or CDN infrastructure that are also providing you with your TR, your trusted recursive resolver, and giving you DO functionality, who also happen to control the DNS records of their clients, their origin servers, they could flip a switch and turn on encrypted SNI for all their origin applications or all their origin sites that they support. So they mass reconfigure all their domains, and then pretty much everyone who belongs to that anonymous set, benefits from this particular design. Caveat again that, depending on how you assign keys in particular DNS records to origins, determines the size of your nominee set. So just a quick recap today, without DO and without DPRIVE. So today, depending on what system you're running, this is what, generally your connection looks like. This is where your traffic goes. So you have a query from a client to DNS recursive resolver for bar, get an address back, send bar and the SNI to this client-facing server, which was identified by the A record. From your recursive resolver and your address, your adversary basically sees everything you're doing. And we want to, presumably if you can encrypt the DNS traffic and encrypt the SNI, both of these holes are plugged. So the high level summary is that the client-facing server, which is the CDN who controls the DNS records for all of its clients, installs ESNI keys, which are key shares used to encrypt the ESNI, into the DNS. Client queries them, gets back an address and a key, and then uses that key to encrypt the SNI as it's sent to the client-facing server. The client-facing server, in possession of the private key in that particular record, can decrypt it and forward it along to the correct backend application. So in this case, we forward it along to bar. The other configuration is the shared mode, where you might happen to have the applications just hosted on the same box, and you just simply decrypt the SNI there, and then use it to serve the right certificate based on what the value happens to be. I should note, though, going back to the previous one, that it is the case that because you don't want to share the SNI keys between the CDN or the client-facing server and the origin, that the origin what websites don't actually see what the real SNI is. So there's a caveat, there's some text in there that says, the origin server has to serve up potentially just one certificate. Otherwise, it just is guessing basically what certificate it should provide to the client. So this is what the record looks like in DNS. It's pretty straightforward. Naming could be improved, I guess. So it starts with a checksum, which is basically the upper 32 bits, or basically the checksum of the rest of the contents of the DNS record, starting from the keys, the key share entry vector, all the way down to the extensions. And we included this basically to protect against potential transmission problems of the DNS record as you fetch it down from the wire. There's a vector of key share entries, which each have a named group, and then something else in there I'm forgetting right now. An array of cipher suites that you could potentially use for encrypting the ESNI. A padded length, which is the length of basically the size of the SNI blob you want to encrypt before sending it to the server. And this is important because you want to make sure that the length of the encrypted SNI does not reveal what SNI you're actually sending. Some not before and not after timestamps that determine the validity of this particular ESNI key record. And this was useful, deemed useful because it helps operators kind of handle key rotation and rollover in a more straightforward fashion. And then some arbitrary extension block if we want to potentially add things there later. And this is all stored in a text record, base64 encoded with the name underscore ESNI with the actual SNI value appended to that. And so, for example, the one that's hosted on the Cloudflare server right now is listed below. I don't know if it's changed since then. I don't think so. Alessandro's here. You can probably give us a heads up. But you can query it right now and find it. So pretty simple. And then once you get this particular record and you have your key share, what you then do is send a new extension, which is the encrypted SNI. It contains a cipher suite, which indicates to the server to the client-facing server, which AAD you use to encrypt the SNI. Contains the digest of the full IETF digest of the DNS record, and this is particularly important to prevent against downgrade attacks because you want to let the server know that this was exactly the set of keys that I used to choose my named group for my key share, and then of course the encrypted SNI value which follows. Key derivation is pretty simple. You have your client key share which has to match the group. One of the groups that are provided in the ESNI key structure, and you mix that with one of the public key shares that's in the ESNI key structure. And this has some interesting effects. In particular, that means that the client-facing server and the origin have to use the same group effectively. The client must send only one because that's the same one that's going to be used for ESNI encryption. But this cipher suite that's actually used for encrypting of the handshake traffic is still negotiated as per usual. The cipher suite that's in the client, the new client hello extension is used exclusively for encrypting of the ESNI, nothing more. And one subtle problem with this right now is the design is specified has a potential for downgrade attacks, and we can get to this later. And this is different from the downgrade attack that I was kind of referring to earlier by including the record digest. So I comment on interactions with mailboxes. Section 9.3 in the text of TLS 1.3 basically requires that a mailbox that does not understand any extension must not send it along. So presumably the server then would reply with a default certificate that the server would trust or the client would trust. So you should have a way to be able to detect this particular problem. But for non-compliant mailboxes, those that just completely ignore this text, unfortunately, and I'm sure there will be some. David Benjamin can probably comment more on whether or not, he's had middlebox problems in the past. So we're not entirely sure how we would detect this particular type of problem. Maybe some kind of captive portal thing, but this is something real this is still very much an open issue. As to the case of disabling ESNI, say you're an enterprise that doesn't want to use it, or say you're a server that is under heavy load and you want to turn it off and stop doing a bunch of encryption, presumably you could just strip the DNS records that contain the ESNI, or the records that contain the ESNI keys from DNS, or just make sure that the TTLs are relatively short, so you're not, your client has to go out and fetch a new record, and then your window of exposure is, the length of that TTL, for example. But you might also want to, if you're a client that's implementing this particular feature, provide a way to sort of push down, a kill switch to a client. So if you eventually just kill off all connections to enterprise applications because of this particular feature, which would not be good, just in note of warning, you potentially might want this ability to turn it off. And there might be some other approach to deal with this particular problem as well. So we're of course open to suggestions for that. And so several times during the design of this particular work, we got asked the question, why not just encrypt everything? And the reason is that we want to make sure that the ESNI is kind of a special beast, and then it's used to primarily identify the certificate, but also potentially used for routing-like information. So if you were to have if you were to encrypt all the extensions, you potentially have to share a key between the client-facing server and the backend, or the origin server, which is not what you want to do in many cases. I mean, if you configure your origin server with a single certificate to respond, then you can keep the keys separate, and you don't have to worry about any particular, key management issue, or at a larger scale, that is. Also, if you happen to encrypt all of your extensions, you might run into middle boxes, which just happen to drop all of your new extensions because they do not understand them, which is a pretty useless client hello, I would say. So, I mean, we could later look at, proposing alternatives to encrypt the rest of the extensions or more of the extensions, for example, the ALPN, if you wanted to shove some, potentially privacy-sensitive thing in there. But for the context, or for the purpose of this particular draft, we explicitly chose not to because we're trying to enable that, that shared and that split topology use case. Also, a very big disclaimer that, most of the content in this draft is potentially wrong. The DNS structure being one of them. We received many comments, particularly from the people in the DNS Ops working group, which was really great because it's nice to have kind of feedback and cross-pollination there. There are issues such as, should we remove base 64? We added it because we all love base 64, and that was a very wise engineering, data-driven decision. There's also talk about potentially using something other than a text record, such as just dedicating a new one for ESNI. Honestly, I'm just deferring to the DNS experts on this particular one who can tell me what the right answer is. So happy to hear that. You might even use, I think it was raised in the HBIz meeting, using alt service to publish an ESNI key structure. Who knows? There's some also problems with the TLS bits of it. Maybe you might not want to use the key share that's used for the actual handshake and used for the ESNI encryption. But the caveat there, though, is that you have to bind them together. Otherwise, someone can just come along and strip out the encrypted SNI blob that you have and shove it in their own client hello, and then send it to the server and get back the certificate that you would have gotten. So there are some proposals floating around as to how to actually do this. We haven't, put anything down concretely in writing yet. But, that is something that we're thinking about. Overall, though, we think, based on our experience at the hackathon and, the ease in which this kind of came out and how it kind of fits seemingly naturally into the ecosystem, that we think this is the right direction. Caveat that we think, and, other people may think differently. So just a quick update on the interop status. So over the weekend, we got it into NSS. Thanks, Ecker. Implemented it in the client side of Boring SSL, and Kazoo implemented it in Pico TLS. Firefox has support, so Ecker was able to connect to Kazoo's website and I think Cloudflare's website as well, which is really great. And we're working on getting it in Safari as well, just to experiment. And there are 2 test servers up right now on Pico TLS and I believe Boring SSL. I'm not sure how that bit is actually implemented, but so that's pretty much it. Hopefully we didn't gloss over too many details in the interest of time, but like now to kind of pose the big question to the room: is this something the working group is interested in? And if so, how shall we proceed? I will take any questions and comments at the mic.
Ben Schwartz, I support adoption.
That was easy.
I'm just going to bother you with weird ideas. I want to put a replacement SNI field in the ESNI keys structure. It can be empty, or in which case you get the behavior where the client doesn't specify an SNI, or it could have something there. I think that could be useful for certain deployment architectures.
So the replacement SNI then would be like, please send, this is what you should actually put in the SNI field. Like, I'm going to greatgrandoldthing.com, which is nowhere near bad, so please don't block my traffic. And you actually put the bad thing example.com in the encrypted SNI. Is that correct?
So I think that seems a little silly, given that the encrypted SNI extension is right there at the end of the client hello. But I think there are deployment architectures where basically there's a front end that only inspects the SNI, and then there's a much smarter back end. And so your topology here requires that front end to be ESNI aware, and maybe there's a version of this where your front end dispatches based on a clear text ESNI that doesn't
reveal all the relevant private information, and then the private stuff is in the encrypted extension. Okay, yeah, thanks. Something to think about.
So we do only have 10 minutes left, and there's 7 people in the line, or 8, so let's keep it short. Thanks.
Davis Kanazi, Apple. So I like this. I think that is a problem that this working group should try to solve, and I think, like, I agree with that this is going in the right direction. One thing I would like the group to consider is potentially trying to also encrypt other things that are in the client hello thanks to this mechanism.
So like I was mentioning earlier with the ALPN, like I'm of the opinion that we should do that in a separate draft because of the reasons that I discussed. That doesn't mean we shouldn't do it here. Absolutely, like encrypting ALPN. I know what your use case is, and
Yeah, that works. Thanks.
okay, very good. Mike?
Mike Bishop, I also think this is moving in the right direction. I will point out one more way in which the draft is wrong, which is that
Great.
it fails to cover multi-CDN cases. And the way it's written right now, you get one ESNI key per hostname, per origin. And in a lot of cases, there are actually multiple CDNs that it might be shared amongst that you probably don't want them to have the same keys. So you have to figure out some way to disambiguate.
Yes, and that is indeed an issue that we're discussing, both amongst the authors, and that's going on in the DNS Ops working group, or on the DNS Ops thread. So, yes, thank you for pointing that out. This in case, or this particular version of the draft does indeed not cover that particular case. So, Brian, I think you're next.
Hi, Brian Trammell. This is a sick hack. There's a lot of details to work out, but I really like it. I think this is the place to do it. I caution you against going to DNS experts and asking them whether text records or an URL are a thing to do. But yeah, it's a detail.
So from
I would say that there does need to be coordination though, because that's a detail that might not necessarily need to get worked out here. Is that okay?
Thank you. Yeah, DKG.
This is DKG. So this is excellent work. I support the working group working on it. Thank you. One thought that would address maybe Mike Bishop's concern is to actually bind these to inatter.arpa instead of to the name. I realize that creates an additional potential latency during lookups, but that could be solved by push situations or other arrangements. The advantage there is that the key that you're looking for is actually the key for the endpoint IP address. And so the linkage that's made is the linkage between the IP address itself, not between any hosts. Anyway, just wanted to point that out. And I have one question for you, which was, does Apple know that you're doing a presentation with Comic Sans?
Apple knows. Apple marketing has no idea. Yeah, Tommy Polly, Apple. So yeah, this is good work. Stop using Comic Sans. We have better fonts. I just want to speak in favor of the current structure for DNS. I mean, I'm sure things will change. I like several properties of it, though, that I don't want to lose as this evolves. I think it's very important that we can do this from an implementation that doesn't have HTTP in it, that doesn't do stuff like altserve. I think it needs to be a fairly low-level thing. We don't want too much of a layer of violation here. I like, despite any problems with stuffing this all into text record, I like that it seems deployable this way, and we're not going to have problems about getting it through. Whatever solution we have does need to solve that problem, so let's keep going down that road. One thought regarding the IP address solution that DKG just mentioned, that's very cute. I'm a little bit concerned about the latency that could add to the beginning. As I was thinking about how I would implement this, because we're doing DNS queries already, happy eyeballs, I was imagining I could essentially do the text record query before I do the A and quad A, and then just fire those off afterwards to make it really fast. If I have to wait to get the IP addresses, now I'm actually doing way more queries, and it's actually forcing me to do it at the end. So we just need to think that through. Thank you. Thank you.
Piotr Sikora, Google. One thing it seems missing here is there is no acknowledgement of the fact that ESNI was successfully accepted and decrypted by the server, or whether it was simply ignored, and then the client doesn't have any indicator whether the negotiation was successful, right? The draft assumes that the web PKI verification will fail in that case, but that's not necessarily true with wildcard certificates and stuff like that, right?
Okay, yeah, certainly something we can clear up in the text. Yeah. Thanks.
Hi, Phil Humbaker, Komodo Security Solutions. I really like the work. I strongly suggest you split the draft into two so that you have all the crypto piece and the TLS piece in one, and all the piece about how you get the parameters out of the DNS in another. And the reason for that is that I have in the past been told many times how easy it is to deploy new resource records in the DNS.
Yes.
And I happen to have two ISPs that support my websites, neither of which will allow any record other than the ones they support. So there has been great hope over experience that has not changed in 15 years. The other thing is that I think that you will find you get pulled into the whole how do we reform how HTTP streams are discovered, and there's a whole thing of should you use SRV or whatever, and DOE is changing that. And I think that you want to have that whole world separate from the crypto stuff.
Interesting suggestion. We hadn't actually considered that. But yeah, we'll talk about it. Thank you. David.
David Benjamin. So I like this draft. I think basically what the slide said is going in the right direction. There's some details to work out. Like I think your hand waving there is probably better about the reusing key share. The hand waving on the slide over there about reusing key share is probably better. One thing that is probably worth thinking about is the draft, at least as is kind of operationally scary in that when there's a mismatch on the key, you sort of have no recourse, like the connection will fail and you are just sad until the TTLs expire. And so if we can avoid weakening the threat model, or maybe if we can avoid like making this totally useless or like, less useful while also like making it deployable, that would be a good thing to get both of.
Yeah, absolutely, I agree. So I would beckon the server operators in the room to sort of, help us work that particular issue out. As a client, I just assume the server works all the time, which is that's the right thing to do.
Eric Niger Nakamai. Actually, I would agree with PHB on I think it does make sense to split the crypto side of it out from the how do we deploy those keys to clients, because I think that how you do that latter may vary based upon from protocol to protocol. Like for the web use case, I think and I dug up some of my notes from when we were going through this 4 years ago, and now I feel really old because that happened a long time ago. In the early TLS 1.3 SNI discussions, we effectively came to a design that looks very surprisingly like the alt service stuff, not surprisingly, but it has a lot of similarities to that. And we had basically the equivalent of this in those records. And that makes it a lot more deployable from a CDN perspective. It solves some of it has some perf benefits from deployability, some ways we integrate with customers' deployability benefits, as well as addresses the multi-CDN case. But that said, that may be appropriate for the web use case, but it would not surprise me if other use cases of TLS might have a better or different way to do it that's not alt service for theirs. I think separating out from the how do we do it perspective, I will add in the should we caveat again on that unfortunately for better or worse, SNI is one of the less harmful signals to middle boxes that they can use to do filtering. And I'm seeing some grimaces, but it's we should think through what are the ramifications of this. There are middle boxes today for enterprise use cases that today will use SNI to do filtering. Whether or not this is a good idea, well, it is not a good idea, but it's what they do. If we take that away from them, it may increase the number of things that are actually trying to do active man in the middle, which is worse.
Is there a line to respond? Go ahead.
Yeah, I spent a little time thinking about this. We already take clients in general, but especially browsers, already take signals from the enterprise about what they should and shouldn't do. There's like enterprise policies, and I think DOE is the same kind of funny property, which is like lots of enterprises would prefer you didn't do DOE because they want to run the DNS a specific way. And I think what's going to have to happen is works as clients ought some way for the enterprise policy to say don't do ESNI. It's not like the most desirable outcome. I want ESNI everywhere, but I also don't want everything to be constantly in the middle or blocked.
Yeah. So, I mean, if you got a better idea, like, I want to hear it, because like, I don't love that idea.
All right, cool. So where we're at, I like that everyone said that they thought it was useful for it to be in this working group because it's clearly in scope. I think that point is not debatable. If you would like to appeal that decision, feel free. I'll write it for you. I don't think you're going to win. In any event, who's read this draft? I find this unshocking. Since we've talked about this for like 3 weeks. I would like to do a call for working group adoption. It was obviously that there's still some stuff to be worked out. Whenever we cross the streams with the DNS people, we have to go figure that out. But I'd like to like at least get it in a working group and get going on an actual, getting the technical details down. Whether we have to split or not, I think it's fine that you leave it together and we can split it out later and maybe it ends up going someplace else, but whatever, as long as we get that stuff in one place. So we're going to do 2 hums, yes for adoption and no for adoption. And Martin, I'm going to try to do it right this time. The first hum, if you would like to adopt this draft as a working group item, please hum now. If you would not like to adopt this working group item, this draft as a working group item, please hum now. For the minutes, it's pretty clear. We're going to adopt it, so.
Really quickly before everyone departs, I quickly skipped over the title slide in which I completely forgot to acknowledge all the co-authors in this particular work. So Eric, Zero, Nick, thank you so much. And this was very much a group effort. Yeah, that's it.
Okay, with that, we're done. Blue sheets?
Good job, man. No, I mean.
Okay.